Okay, so today our page 126 says graphs in the media. Does anybody know what media is? No. Emmett?
I think it's like online stuff, so it's like Instagram, Snapchat, and the media.
Yeah, that's social media. That's perfect.
Yeah.
Good. Other media could be, oh, Lacey, I'll let you answer for sure.
Does the media mean like the media and the government?
The government uses the media sometimes. Totally good connection. Willow?
The news.
Yep, the news. Good. Media. So you can watch media on your computer, your TV. Media could be like TV shows. It's now the word sounds weird. I've said it too many times, media. But yeah, so just information that you're getting online, on the computer, on TV, just media. So today we're just going to learn how to find and interpret graphs using the media, because sometimes if you're watching the news, you're watching a show or something, they might have a graph out on there for you where people voted. They'll show you, there's so much data they can show using graphs. So this lesson hopefully will teach you how to read those graphs. So if you look at the little paragraph there, it says Alec completed an online weekly survey at the official website of the 2010, so this is 10 years ago, Winter Olympic Games in Vancouver. So this guy, he went online and he made up a survey for the 2010 Winter Olympics. So he asked a question, and he asked people to name their favorite Paralympic event. When he completed the survey, then the bar graph below was made. Does anybody know what the Paralympics are? Emmett?
I think I have an idea. The Paralympics, like it's a duo. It's two people in the Olympics together doing stuff together.
That is a really awesome connection, because you heard the word pair, right?
Yeah.
That's awesome. It's not quite the right answer, but I really like how you used a word you knew. That was a really good job. Lacey?
It means you're doing a sport with a missing limb.
Yeah, or just a disability in general. So if you had some sort of disability, you would be in the Paralympics instead of just the regular, not normal, but the regular Olympics that everyone else would compete in. So that we start off with the Olympics and then the Paralympics are after. Good job, Lacey. Awesome. So this guy went on a website, he made a survey, he asked people to complete or to answer what their favorite event was, and the graph below is the information that he got. So if you look at the question in red, it actually asks you to think of what questions you can answer about graphs that you find. So if we look at the graph above, what are some things that you notice? So what do you notice? Willow?
That some of them aren't exactly on the line.
Good. So it's not an exact number. Perfect. Lacey?
That it's going up by 38.
Yeah, thank you. Sorry. Good. Just looking at my email quick. You're right. They are going up by 38. And if you wanted to tell that really easily, instead of trying to add like 38 plus what equals 76, you could look, because the graph starts at 0 and then it jumps to 38. That means they went up by 38. So good eyes. Nice. Okay. So the scale is 38. One box is 38. What else can you notice? Emmett?
So what I noticed is alpine skiing and ice sledge hockey is it's more popular than Nordic skiing and wheelchair curling.
Good wording. So you could say alpine skiing is the most popular, ice sledge hockey is the second most popular, and then you could talk about other things too. What else could we talk about, Bennett?
The graph is sideways.
Yeah, it's a horizontal bar graph. Good. Nice. Lacey?
That there's boxes and using the color, and then it says a number and the like a number and then the name of that sport.
Awesome. So
Bottom.
you're right. There is a legend at the bottom. So it says alpine skiing is green and the number is 188. Nordic skiing is 57 and orange. So that's a really good thing to notice, the legend. What other information can you tell from this graph? So Emmett said that alpine skiing and sledge hockey were the most popular. What else can we tell? Willow?
We can tell what they're talking about because it has a title.
Awesome. Perfect. We can tell what the question is that they were answering. Awesome. What else about the bars do you notice, Lacey?
That they're all different colors.
Yep, they use different colors, which is smart to keep things in order. Good. So if Emmett said that alpine skiing and sledge hockey are the most popular, what do you think the least popular are then? What does the graph show you is the least popular? Bennett?
I don't know how to pronounce this one, but
Yeah, you got it. Nordic. It's exactly the way it's spelled. Nordic skiing.
Nordic skiing and wheelchair curling.
Awesome. Yeah, so the very least popular one was Nordic skiing, and then wheelchair curling was the third. So that's really important information that you can get from the graph. And that's pretty much it. If you look at it right away, you can see what's the most popular and the least popular. And that's why people use bar graphs, because they're really easy to read. So if you go to our worksheet for today, lesson 5, graphs in the media. Okay, we're there. It's asking you to just answer kind of the same questions. And then at the end, it asks you to ask your own questions about the graph. So we can talk about that really quick. I'll just read through it for you or with you. The goal still is to find and interpret graphs using the media. Diane found this graph through the internet. She wrote some questions about the graph. So the topic you can tell already, or the question that they asked, was about favorite winter activities. The choices, snowboarding, dog sledding, skating and hockey, skiing and snowshoeing. If you look along the bottom, it shows the scale of the graph. So how much does each box show? How much is each box worth, or what is it going up by? London?
2.
2, yeah, it's going up by 2. Awesome. Yep. I might have even just answered a couple of the questions. So that's something you can notice. If you look at the graph right away, you can probably tell which one is the most popular. Emmett, do you have a question or an answer? A question? Okay, I don't want you to answer the questions because I want you to do this on your own, but what's your question?
My question is, it glitched out, so what page are we on?
Oh, sorry. We're looking at that page. So the one that you're working on today.
Oh, the one we're working. Okay, got it.
I think the Langdon Wi-Fi today is glitchy all around. So if you look at number 1, you're just going to answer the question. So what does this graph show? You could write what the question they asked was. You could write the title. Number 2 says which activity was the favorite for most people, which activity was the least favorite. Number 4, which activity was chosen by about 13 people. About would mean that it's not exactly on the line, but it's close to 13. And then number 5 is more of a challenge, but I think you'll be able to do it. We did this last year. We made graphs and then wrote questions about them. Write your own questions about the graph, and then I keep saying graph, to There's no T. Then you're going to answer your questions. So a question about a graph, if we go, you don't have to go back to this page, but I'll just show it to you. What are some questions that we could have asked for this graph? What could we ask that we don't already know? Lacey?
What is the exact number for alpine skiing?
So that, I guess you could ask that and they'd have to refer back to the graph. Yep, you could ask that. So you could ask numbers of things. Those are good questions. What else could we ask? Willow?
Why did they pick the question?
Can you answer that though? Do you know why they picked the question?
No.
That is a good question for like if your friend was doing a graph, but remember this is a graph that would be like in a newspaper or on a website.
Oh,
You can't ask the person that made it, but that would be good if you were in class and did a question. What about, do we know how many people they surveyed? No, but could you figure that out? Yeah, all you'd have to do is add up all these numbers. So that could be a question. How many people did you survey? You could also ask questions like how many more people liked alpine skiing than ice sledge hockey? So you could try to figure that out, and you'd have to take this amount away from this number to see how much is between them. So that's a question you could ask. You could ask how many more people like Nordic or ice sledge hockey than Nordic skiing. So there's a ton of other questions you can ask about graphs. Just make sure that you can use the graph to answer the question. Does that make sense? Yeah. Okay, so that's that sheet. All done there. So let's look at page number 128 now. So just like you said before, we are going page by page pretty much in the textbook. Okay, so the second half of this lesson is sort and classify numbers using Venn diagrams. We know what sorting is, but does anybody know what classify means? Lacey?
Classifying means like ordering it?
Yeah, kind of, putting it into the right section. Yep. So like I classify this number as even. I classify a cat as a feline animal. Good. Okay, so let's get right into it. Venn diagrams are always used to compare things, to see how they're alike and how they're different. You need a bunch of objects to sort. So Michael, Haley, and Diane, feels like it's always the same kids, attended a math fair. Each student can win a prize by correctly sorting 12 numbers using different kinds of Venn diagrams. So we'll look at Michael's sorting. He used a Venn diagram with two separate circles. That's not very common because I guess it is still a Venn diagram, but really you just circled the even numbers and circled the odd numbers. So his are two different Venn diagrams. Haley, if you look over on page 129, she sorted the numbers using the Venn diagram with overlapping circles. So, I wish this iPad worked. If you look at her Venn diagram, there's a circle here that says 3-digit numbers, and this circle says even numbers. What does it mean if numbers are in the middle? Bennett?
I think it might be they're both.
Yeah, they're 3-digit numbers and they're even numbers. And then what about the numbers off to the side? What do you notice about the ones that didn't make it into the circles? Emmett?
I noticed that they're all uneven and 3 of them are 4-digit.
Yep, they're all odd or uneven, and there's a 1-digit and a 3 4-digit number, so they don't fit in any of the circles. So the 3-digit numbers that are odd are in this circle. All the even numbers are in this circle, and then even 3-digit numbers are in the middle. So that is what that means. Then Diane, she sorted the numbers using a Venn diagram with a small circle inside a big circle. So if it wasn't going to be more confusing, we just decided to put one inside the other. So if you look at the labels, it says 4-digit numbers, and then the inner circle says even 4-digit numbers. So all Diane did was put, she probably started out by finding all the 4-digit numbers because that's what's in common with both of these circles. And then she just circled the ones that were even. And if you look on the outside in the big circle, it's all the odd 4-digit numbers. So there's a lot of different ways to make Venn diagrams. Does anybody have any questions about what the circles mean or anything? No? Okay. So these 3 Venn diagrams all deal with numbers, but and I guess our questions on our worksheet are going to use all numbers as well. Sorry about that. Something in my throat today. But, and we're going to do 3 examples on the worksheet. So why don't we go to page 130 and just walk through 1 or 2 of these examples. I don't want to take up too much more time, but just so that we have a kind of an understanding, and then I will let you go and I'll eat my lunch. Okay, so page 130, number 1, it says under checking. It says Stacy was giving a Venn diagram and sorting and some numbers to sort. It says copy and complete Stacy sorting. We're not going to copy and complete, but what are the 2 labels on the circles? Lacey?
Even numbers and 3-digit numbers.
Good. And then Lacey, what goes in the middle then?
3-digit numbers that are even.
You got it, girl. So if that's the case, if you look at the bottom numbers, she hasn't sorted those ones yet. Can anybody tell me where 505 would go? Where would 505 go? Would it go under 3-digit numbers, even numbers, or even 3-digit numbers? Willow?
It would go under 3-digit numbers.
Yeah, because there's 3 digits in 505 and it's odd, so it can't go into even numbers, and it can't go in the middle because it's odd, so it stays in the 3-digit circle. What about 81? Where would 81 go? Lacey, you're on fire today. Where does 81 go?
I'm thinking in the numbers, like just outside of the circles.
You got it, girl. Yep, outside. It's not a 3-digit number and it's not even, so it can't go in any of the circles. Good. What about 64? London?
It will go into the even.
You got it, because it's even, but it's only 2 digits, so it can't go in the middle. Awesome. What about 72? Willow?
Would it go in the middle or would it go on the outside?
So 72, Willow, is 72 even or odd?
Even and odd, because 70s.
Oh, good point. So when you're looking at an even and an odd, to figure out if a number is even or odd, if it has more than 2 digits, or more than 1 digit actually, you look at the digit in the ones column. So we look at the 2, and then you decide is 2 even or odd.
So it goes in the even.
Yeah, exactly. It would go in the even numbers. Good. What about 1,000? Emmett?
It would probably go outside.
1,000? Ooh. Anybody else want to take a guess? Bennett?
I think it might go in the even numbers.
Yeah, so 1,000, a 0 we know is just 0, so it's hard to decide if it's even or odd, but 1,000 is kind of like 10, and 10 is even. It ends in a 0, so 1,000 is even, and but it has 4 digits, so it just goes in the even side. What about 310? Lace?
It would go in the middle.
Yeah, because 310 is both even and 3 digits. And then the last one, 4,561. Look at that last number. Is it even or odd? How many digits does it have? Faith or Willow, do you know?
Does it go on the outside or on the 3 digit?
Oh, no, you are right. It does go on the outside because it's 4 digits. So it can't go in the 3-digit numbers. It can't go in the even numbers circle. So it just floats around the outside because it doesn't fit in either of those categories. So basically all we're doing here is sorting things. You're just gonna look at each number on your worksheet and say, does it match what the headings are? So let's look at page 34. The one that is your, sorry, the sheet. Lesson 6. Got it? Almost got it. Okay, so number 1 says sort these numbers using the Venn diagram. Now this one should be easy because it's just one circle that says odd numbers and one circle that says even numbers. Basically, guys, if you can count by 2 and get to a number, it's even. So that's a big hint for you. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, blah, 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 2,222. They're all even. So if you can count by 2s, it's even. So yeah, you're just sorting them into the odd numbers or the even numbers circles. The number 2, it says sort these numbers using the Venn diagram. So the 1 circle says 2-digit, the second circle says even numbers, and in the middle would be 2-digit even numbers. I know they're really small, the bubbles, so try your best to fit the numbers in there. Number 3 is one of those weird ones that kind of look like an eyeball a little bit. It says sort these numbers, again, using the Venn diagram. So the big circle is 3-digit numbers, and the littler circle is even 3-digit numbers. So the even numbers go in the little circle, and the odd 3-digit numbers go in the big circle. Does anybody have any questions about those 3 questions? Questions about the questions? No, we're feeling good. Can I ask you guys, can you look at the next page in under Thursday? And do you have this page, lesson 7? Yeah? Okay. Carol diagrams. Those ones are weird. So we will go over that tomorrow. We'll learn what it is. And then, so that's the only page for tomorrow. And then on Friday, there's a page that's just kind of making your own graphs, which we haven't really done yet. And it's review. So tomorrow I'll go over both those pages and then we don't have to have a lesson on Friday. Does that sound good? I'll still have office hours. So if you get to something and you're like, I don't understand, you just come pop in and we will go over it. Okay? All right, guys, thank you so much for coming to our math lesson. I will see you tomorrow at 9:30. Bye.